Next, we will see that Carnot engine is a very important 5 mark question in this lesson. So watch it carefully. So Carnot ideal heat engine. Okay. So in the previous section, we have already discussed we cannot producing 100% of efficiency while using heat engine because there is a loss of heat will be there. Okay. But that French engineer, Sadi Carnot is the name. So he proved that certain reversible engine can operate in cycle between hot and cold reservoir, that is a TH and TL. Okay, can having a maximum efficiency, okay, at most. So this type of engine is called the Carnot engine. Okay, so now I will define the Carnot engine. A reversible heat engine operating in a cycle. Reversible heat engine operating in a cycle between the two temperatures, which means we have to vary the temperature of between two things in a particular way. This is called the Carnot engine. Sometimes the temperature will be constant or various. Okay, so we can producing at maximum of efficiency of the heat engine in a reversible process. Okay, that is the meaning of Carnot engine. Okay, so Carnot engine having a 4 major parts which I have shown you figure now. Okay, so first thing is called source. So source means we are getting from the type of the source only. This meaning of source of temperatures. It's always maintained at high temperature, say TH. Okay, source of heat maintained at a constant high temperature, say TH. So any amount of heat can be extracted from it. Okay, without changing its temperature. It means so we can take the amount of heat energy from source means then it gives the same temperature. Okay, so how much of heat energy will be taken from this source means after that it will be maintained the same temperature. Okay, that's the meaning of source. Next is sink in TL. Is a cold body maintained at a constant low temperature TL. It can be absorb any amount of heat. Source is providing heat energy. Sink means absorb the heat energy. Okay. Third is called insulating stand. Insulate means it does not conduct heat through on it. Okay, so it is made up of a perfectly non-conducting material. Okay, so that heat is not conducted through this sand. Okay, then fourth one is a very important, working substance. Okay, it is an ideal gas. Okay, getting gas is a working substance. It is enclosed by the cylinder. Okay, but cylinders, the walls are made by the insulating, which means the walls of the cylinder does not conduct the heat through on it, but the base, the bottom of the cylinder is made up of that conducting material. Okay, so which can conduct the heat through only the bottom of the cylinder, not through by the walls of the cylinder. It is attached with the piston. It's a movable piston. Okay, clear? Source providing heat energy. Sink absorb the heat energy. Insulating stand does not conduct heat through on it. Is a working substance as an ideal gas. So walls cannot conduct in heat energy. The bottom of conduct the heat energy conduct. Okay, let's see what is the Carnot engine cycle. First, the working substance. Okay, it is placed on that source. What will happen? The amount of heat energy from the source will be transferred to the ideal gas as a working substance, so that the volume, pressure, temperature of that ideal gas will be changes. According to that, it absorbs the heat energy from the source. Okay, so heat is transferred. So what is the concept? Is the meaning of isothermal process. Correct? So temperature of the two system here, working substance and source all constant after sharing this temperature, which means T is constant. It's called isothermal process. Okay. Then we have to place the insulating working substance on the insulating stand. Okay, now the temperature is not transferred from the cylinder to the stand. Okay, so both are having maintained at different temperatures. That is called adiabatic process. So that the temperature of the two things are be variable. Okay, next we have to place that ideal gas on the sink. So what will happen? The heat energy flows from working substance gas to the sink, because sink absorbs the heat energy. After that, both are made in the same temperature. So it is called what? Isothermal process again. Okay, so pressure, volume, temperature also, temperature only changes, pressure, volume also changes. Sorry, temperature remains constant after the shining the temperatures from the gas to the sink. Okay, and finally you can place that gas on the insulating stand. That time also the temperature of the gas is not transferred to the insulating stand, and also maintain that same additivity process. Simply say gas on the source is called isothermal process. T is constant, but PV all changes. Next, gas is placed on the insulating stand. Temperature is not constant; it's variable because temperature is not transferred from gas to the stand. It's meaning of adiabatic process. Third thing, we place the gas on the sink. Temperature is transferred from gas to the sinks. Okay, so pressure, volume are variable. Temperature remains constant. This is called isothermal process again. Finally, we have placed that gas on the stand. This time the temperature is not variable. Okay, it's not transferable, so that it also maintain the additivity process. Okay, so let's see is what is the temperature, volume, pressure changes from according to this cycle. Okay, with that the work done function. Okay, now we'll see the PV diagram for the Carnot engine, pressure volume diagram. So the volume is taken in a x-axis, pressure taken in a y-axis. Okay, put the point here at initial stage. The volume is V1, pressure is P1, temperature is TH. Now we have to place that gas on the source. The temperature remains constant because of pressure is transferring from source to the gas. Okay, it maintains that isothermal process up to here. Since volume, pressure will be changes, temperature remains constant, same TH here. Okay, it's called expansion, means the volume will be increases, pressure will be decreases. So A to B is called isothermal process. So we have to see the work done also, so we'll see later. Next, B to C. Okay, so now we have to place that gas on the insulating stand. So temperatures are not transferable, so temperature is variable, and then volume also, pressure also variable. See, volume changes V2 from V2 to V3, pressure P2 to P3, temperatures TH to TL. So temperature all variables means it's called adiabatic process. So the reaching B to C is called adiabatic process. Now we have to place that gas on the sink, which means the temperature of the gas will be transferred to the sink. So temperature is transferable, so maintain the same temperature after that, and pressure and volume also changes. So volume changes from V3 to V4, pressure is P3 to P4, temperature remains same. It's called isothermal process. Once again, you have to place that gas on that stand, which means temperature is not transferable. So volume changes from V4 to V1, P4 to P1, temperature is all TL to TH. It's called adiabatic process. Okay. Now we'll see that work done in the Carnot engine. So first process A to B. So this is the work done by the gas. Second is B to C. This is work done, okay, on the gas. Third, C to D. This is work done by the gas. Fourth one, D to A, work done on the gas. So the strategy shows that work done. So that only we have to see now. Okay. So we have to find out the work done of the each process. Okay. Isothermal process, adiabatic, isothermal, adiabatic. Okay. So see the diagram. It shows that Carnotic cycle. It shows easily. Okay, we can understand easily. First, gas placed on the source. Temperature is transferred to the source to the gas. Okay, it's called isothermal expansion. Then gas placed on the stand. There is no temperature flowing between these two. It's called adiabatic expansion. Third, gas is placed on the sink. Temperature from the gas flows to the sink. So it's meaning of isothermal process. Finally, again place the gas on the stand. The temperature is not flows between these two, so it's called adiabatic compression. So expansion for both the first two things, compression for the last two things. Okay. So final work done or net work done in the cycle means you have to remain this work done only. From A to B is the isothermal expansion. B to C is adiabatic expansion. C to D is called isothermal compression. D to A is what? Adiabatic compression. So the shaded region is called work done in the Carnot cycle. Okay. Now see the Carnot engine cycle's formula. First is step A to B, which means cylinder is placed on the source. Okay, so we have seen the work done. There is amount of heat energy of the hot reservoir QH is equal to work done from A to B. That is equal to formula for work done equal to P dV. The volume changes. So volume changes from V1 to V2 and P into dV. Okay. So this is meaning of what? Isothermal expansion. You know the isothermal expansion formula. Okay. So work done from A to B is equal to, for expansion formula mu RT. Mu RT is a high temperature, then ln of E2 by V1. This gives the area under the curve AB. Area under the curve AB. Okay. Similarly, we can find out the second step. That is step B to C. Now cylinder is placed on insulating stand. Okay, so the work done. Okay, so what is this process called? What? Adiabatic expansion. This is the process here. So the work done equal to from B to C is equal to what? V2 to V3. The volume changes here. Say P dV for the work done. For adiabatic means the formula is various. There is mu R by gamma minus 1. High temperature is what? TH minus low temperature TL. That is equal to area under the curve. BC. Similarly, for the third step, steps C to D. Now cylinder is placed on the sink. Cylinder is placed on the sink. It's the meaning of isothermal compression. Isothermal compression. So that work done C to D is equal to, okay, what's the volume here? V3 to V4 P into dV, that is equal to mu RTL ln higher volume V4 by V3. Now changing that volume, okay, so it will become the minus in the thing, okay, mu RTL ln V3 by V4. This meaning of minus of area. What is minus? By changing the numerator diameter become minus here for the ln area under the curve CD. Similarly for the last step, step D to A. Cylinder is placed on the insulating stand. Placed on the insulating stand. Is the meaning of adiabatic compression. Adiabatic compression. So formula here, W equal to D to A is equal to V4 to V1, then P dV is equal to mu R by gamma minus 1 TL minus TH. Okay, so the volume will be changes here because L to H, so that is minus of area under the curve dA. Okay, so we have to combine all the work done. Okay, so the net work done W is equal to, okay, work done by the gas, work done by the gas minus of work done on the gas. work done on the gas. So its meaning of for expansion is work done by the gas. Compression means work done on the gas. So we'll let us work done A to B plus work done B to C minus of work done C to D plus work done D to A. Okay. So finally we have only both are same cancel to each other. Okay. Finally we'll get as the formula of work done A to B minus of work done C to D. These both are cancelled because both are having the same in adiabatic process. Okay. So the net work done by the Carnot engine is one cycle W is equal to W A to B minus of W C to D. Okay. Now we'll see that efficiency of a Carnot engine is a separately 3 mark question they will ask, is important. Okay. So you know what is the form of efficiency? Eta is equal to work done by heat or extractor. Heat extractor. So what is the work done means W, then QH is the formula. Put the equation number 1. Okay. From the first law of thermodynamics. From first law of thermodynamics. So what is the meaning here? The work done is equal to the change in the amount of heat energies, that is QH minus QL. Okay. So we are applying the W formula in the first equation. Substitute in the first equation. Eta is equal to QH minus QL by QH. So after the simplification of these two, cancel each other, become 1 minus QL by QH. Put the equation number 2. Okay. Now we have to apply that isothermal conditions. Applying that isothermal conditions. So that we can get the QH value. So QH means for the isothermal expansion. So that formula will be mu or TH ln. The volume changes from V2 by V1. For the lower temperature of the amount, mu or TL ln V3 by V4. Actually, V3 by V4. Okay. Now here we have to omit the negative sign since we are the interested in only the amount of heat energy is QL, which is exerted to the sink. Okay. So we have to divide these two. Okay. So QL by QH is equal to we know the formula mu or TL. Okay. It will change the temperature in low temperature, so mu cancel, or cancel. Clear? Right. Mu or TL of ln V3 by V4 by mu or TH ln of V2 by V1. Mu cancel, or also cancel. We have these two equations only. So TL of ln V3 by V4 by TH of ln V2 by V1. Okay. Now we know the relation between these two. For using that, applying the adiabatic conditions. Applying the adiabatic conditions. So what is the formula for adiabatic condition between T and volume means temperature volume power of gamma minus 1 is equal to constant. So applying here we will get temperature is what? TL. So it will become TL, then volume is V3 power gamma minus 1. It's a numerator. Then divided by diameter is V4 no. So TL V4 gamma minus 1 divided by TH V2 gamma per minus 1 divided by TH V1 gamma minus 1. Okay. So it's the numerator diameter both are in the same numerator. So we have to find out this thing means it will be changed as TL V3 gamma minus 1 by TL V4 gamma minus 1. The derivative we will write as the multiple means changing the things. So TH V1 gamma minus 1 by TH V2 gamma minus 1. TL cancel, TT is cancel. Okay. So we have the formula like that. V3 by V4. Okay, become V3 by V4 power of gamma minus 1. Okay, then bring this the V2 V1 the left side, so we will write as, we will go to multiple now, so put V2 by V1 power of gamma minus 1. Okay, we're getting like this, which means both the powers are cancelled, so we will write as V3 by V4 is equal to V2 by V1. Put the equation number 3. Now we have to substitute 3. Sorry, keep this equation as a 3. This is a 4. Now you have to apply the 4 in the third equation. Substitute the equation 4 in 3. So V3 by V4 equal to V2 by V1 means we'll have TL ln V3 by V4 by TH ln. So we have V2 by V1, we'll write as same V3 by V4. So both the ln same value means cancel to each other. So finally we have TL by TH. This is substitute in the first equation here. Sorry, in the second equation. Sorry. So TL by TH we will write as meaning of QL by QH. Okay. See in the third equation we have QL by QH is equal to two lines are cancelled to each other. We have TL by TH. This substitution in the equation 2 means we have QL by QH now. We will write as for TL by TH. So this the equation becomes eta is equal to 1 minus QL by QH is equal to what? TL by TH. So this is the formula for the efficiency. Okay, note here both the temperatures expressed in a Kelvin scale. A Q is called amount of heat energy in terms of joule. T is meaning of temperature in terms of Kelvin. Okay, so here the eta is always less than 1 because TL is less than TH. Okay, this implies the efficiency cannot be 100%. It can be 1 or 100% of only when TL equal to 0 Kelvin, but it's not possible. Okay. The next topic is the second law of thermodynamics and entropy. So entropy means the quantity QH by TH. Q is amount of heat energy, T is temperature. Okay. So the quantity QH by Q is equal to Q by TL. Okay. So where Q by T is called entropy. So entropy means we have to divide by the energy by the temperature. Okay, it's a very important thermodynamic property of the system. It is also state variable because QH by TH is the entropy received by the Carnot engine from the hot reservoir, whereas Q by TL is what entropy given out by the Carnot engine is called reservoir. Okay, clear? So we can have the second law of thermodynamics as follows like this: for all the processes that occur in nature is called irreversible process, that entropy always increases. Okay, clear to me? Entropy means the ratio of Q by T. For reversible process, entropy will not change. Clear? Is very important. So that entropy determines that direction in which the natural process should occur. Once happened means it's never come back. That is the meaning of irreversible process. Okay. So the direction of entropy is same for the natural processes. Okay. Next thing. Entropy increases when heat flows from hot to object, cold object. Yes. If heat were to flow from a cold to hot object, entropy will be decreasing. Correct? That is leading to violation of the second law of thermodynamics. So what is the concept? The entropy increases when hot to cold, or entropy decreases from cold to hot. Okay. So the entropy we can also define as, it's called as a measure of disorder. Okay. So all natural processes occur such that the disorder should always increases. Okay. So that is the meaning of entropy. Okay.